Hello, today we're going to be looking at locus again. In particular, we're going to be looking at a circular locus, like we can see here. So the locus condition is the distance from P to A is equal to R, and R is just some constant. So in this case, R is going to be 5, and we came up with this. Our A is 0, 0, and it gives us a circle. So if you were exactly 5 units away from this point at all times, you're going to make a circle, which is what we can see here. Now, like the last video, I'm going to link this particular graph down below in the description, so you can have a little bit of a play around with it. So some of the things that you can do is you can actually change the A coordinate by just clicking and dragging it, and you can just fiddle around with positioning. You can also drag this R slider on the side here to change the radius of the circle. And of course you can see the actual equation up here, and you can do some alterations and experiment with it if you want to. So with that, let's actually get started. Okay, to get started, we're going to have to define uh, our locus condition, which I said earlier was PA and equals some constant R. So I'm going to let that constant be 2. So bear in mind that this could work with any number as long as it's real. So moving on, let's define what P is. So P is going to be X comma Y, and I'm going to make A my center point, if you would, going to be 1 comma 1. So let's plug this into the distance equation and let that equal 2. So we'll get our first x value, P, which is x, and then we're going to subtract the x coordinate of A here, which is 1, square it, add, open bracket, our y coordinate for P minus our y coordinate for A, 1 squared, and there we go. We have a distance equation that equals this. So now we can square both sides, and we get x minus 1 squared plus y minus 1 squared equals 2 squared, which will become 4. So what we just did is that we've took the distance equation and we've transformed it into the circle equation. And what the circle equation is that it's just x minus the horizontal shift squared plus y minus the vertical shift squared equals radius squared. You can see how this works if you just sub a for h comma y and sub our constant 2 for r, and you can get this result really easy. What ends up happening is that you'll get a point h comma k, and then you'll go radius distance away, and then you'll just make a perfect circle like so. And that's what we saw on our Desmos graph earlier. We saw that it made a circle, we saw that it was exactly a radius apart, and we saw that we could change the center point to whatever we would like with this h and k value. So I encourage you to go check out the Desmos graph and play around with it yourself, so you can try and get a better understand of this particular locus. Now you quite often might see something like you get this circle equation and then you just divide everything by r squared. So you'll go to x minus horizontal shift squared plus y minus vertical shift squared, and then divide everything by r squared, and that equals 1. That is also technically the circle equation. We've just divided everything by r squared. So that's all the time that I have for today on locusts. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.